Hi, I'm Stefano Ghirardello,
And I'm Jan Westman.
and we're here to talk about biomass power generation.
Now we'll talk about current problems with power generation. The majority of the world's power generation is through the burning of fossil fuels, which is bad. Why are fossil fuels bad? Extracting fossil fuels is harmful to the environment. Fossil fuels come from finite sources, and burning fossil fuels is a major contributor to greenhouse gases.
So how do we fix this problem? It's renewable energy.
What is renewable energy? Energy that is produced from resources which are continually replenished. Renewable resources include wind, sunlight, rain, tides, waves, and biomass.
So what exactly is biomass? Biomass refers to various materials such as wood waste, agricultural residues, and animal and human waste. The majority of biomass utilized is a lignocellulosic fiber such as wood, straw, and stalks.
Why biomass? Biomass is a versatile, renewable fuel which can be utilized in many ways to produce a usable energy source. Biomass generation makes use of agricultural and industrial waste.
So how do we harness the energy from the biomass? There are four main methods which are used: direct combustion, co-firing, pyrolysis, and gasification.
Now we'll talk about direct combustion. This is the burning of biomass in large boilers to produce a high-pressure steam. The steam turns a turbine which is connected to a generator, and the generator produces electricity.
This is shown in the animation scene here. So the biomass is fed into the combustion chamber where it is converted into steam. The high-pressure steam then turns the turbine, and the turbine is coupled to a generator which creates the electricity. Also, some of the steam returns back into the combustion chamber via a condenser.
Now we'll talk about co-firing. This is a cost-effective method entailing the burning of biomass along with coal, oil, or natural gas in existing power plants. Co-firing can be conducted in three different manners.
The first manner is blending the biomass with the coal directly on the fuel pile. This is the least cost approach of the three, and typically the fuel blend can consist of 5 to 20% of biomass by mass. The second method is separately injecting the biomass into the boiler. This yields a greater percentage of co-firing and hence a higher efficiency, but it entails a larger amount of fuel pretreatment needed.
The third method is gasification-based co-firing. This involves feeding the biomass into a gasifier to produce gas. The produced gas is then fired into the boiler. This is the method with the largest capital cost of the three methods explained. This serves as the only co-firing method which can be implemented with natural gas power plants.
Now we're going to talk about pyrolysis. Pyrolysis is the thermal decomposition of biomass occurring in an oxygen-free environment. It can be conducted using two different methods, either slow pyrolysis or the more commonly used fast pyrolysis.
Now we'll explain the pyrolysis methods in detail. Slow pyrolysis takes several hours to complete, and the main byproduct is biochar. Fast pyrolysis, in contrast, takes only seconds to complete, and the byproducts include 60% bio-oil, 20% biochar, and 20% syngas. Essential features of fast pyrolysis are very high heating and heat transfer rates, and the rapid cooling of pyrolysis vapors to produce bio-oil.
So let's talk about the pyrolysis byproducts. The first one is biochar. Biochar can be mixed with soil for gardening and environmental needs. One advantage of biochar is it can store the carbon dioxide within the soil, and it reduces the methane and nitrogen oxides emissions from the soil, leading to a reduction in greenhouse gases. Biochar also increases the available nutrients for plant growth and water retention.
One byproduct is syngas, and this will be discussed in the gasification section. Another byproduct is bio-oil. This is a liquid containing a similar composition to biomass, except with a much greater density. This liquid serves as a great agent for co-firing, and it can be converted into an engine fuel for internal combustion engines.
So now we're going to talk about gasification. Gasification converts carbonaceous materials into into a gas composed of hydrogen and carbon monoxide within a gasifier. The biomass is exposed to high temperatures, usually greater than 900 degrees Celsius, and a gasifying agent such as air, steam, or oxygen, and the result is a syngas.
So what happens inside the gasifier? There are a number of different chemical reactions. Some of these chemical reactions produce the hydrogen and carbon monoxide needed for combustion. Some of the other chemical reactions produce the heat energy which are needed for the chemical reactions which produce hydrogen and carbon monoxide. The result is syngas, which is a gas composed of hydrogen, carbon monoxide, methane, carbon dioxide, water vapor, nitrogen, and various tars.
So now we're going to talk about syngas conditioning. The raw syngas contains particulate matter and tar which is not suitable for an internal combustion engine. The tar is removed through a process called tar cracking. Basically, extreme heat breaks the chemical bonds within the tar to form additional carbon monoxide and hydrogen. The ash, or formerly known as particulate matter, is filtered out of the syngas through bag filters.
The result is conditioned syngas. The filtered syngas can be burned within an internal combustion engine to produce electricity and heat.
So now we're going to talk about environmental impacts of biomass generation. The biomass generation does not cause a net increase in CO2 in the atmosphere, hence reducing the greenhouse gas emissions. Basically, the biomass absorbs CO2 from the atmosphere through photosynthesis when the biomass is in its tree form. It then releases this CO2 once it's combusted. Also, biomass generation produces significantly less nitrogen oxides compared to traditional power plants.
Here we see a graph showing nitrogen oxides reduction during co-firing. As you introduce more biomass in the combustion chamber, you can see that the production of nitrous oxide emissions is decreased.
So let's look at the economics of biomass generation. Compared to traditional diesel, natural gas, or coal power plants, biomass plants have a much higher capital cost. Co-firing is the least costly method of biomass generation because it can be implemented within existing power plants with minimal modification.
Now we'll talk about a biomass fuel comparison. Wood serves as the most desirable biomass fuel source for all biomass generation methods. The extent of the wood pre-treatment depends on the method being implemented.
The moisture content, which is the amount of water within the biomass, is one of the main factors in the performance and the efficiency of the biomass plant. Each method has different acceptable moisture contents. The direct combustion and co-firing each need a moisture content less than 60%, while pyrolysis needs to be around 10%, and gasification needs to be within 10 to 20%.
Particle size is also an important factor. Each method requires different particle sizes for proper operation and performance. The acceptable particle sizes per method are as follows. Direct combustion can use many different particle sizes, and the size is usually dictated by the use. Co-firing needs particle sizes of less than 6 millimeters in diameter. Pyrolysis needs particle sizes of less than 2 millimeters in diameter, and gasification can use particle sizes between 20 and 60 millimeters in diameter.
Now let's look at the efficiency of biomass generation. So typically, biomass generation processes have a much greater efficiency than fossil fuel-fired power plants. A typical coal power plant usually runs at an efficiency around 25%, while biomass generation is able to achieve efficiencies up to 90%.
Now to recap. Biomass is a versatile material which can be converted into heat or electricity through direct combustion, co-firing, pyrolysis, or gasification. Biomass generation serves as an efficient, environmentally friendly, but expensive alternate for power generation.
Thank you very much for listening, and have a great day.